This last part of the lecture is about wave interference. Interference is another word for superposition. So what happens if you have two waves and you add the signal? Here, so this is what's done here. We have a wave 1. Okay, it's a little formula, and we assume it's of, where's my, here. We assume that it's of sine form with a certain amplitude, certain wavelength, certain period, and we have a wave 2, which might have another amplitude, another wavelength, and another period. Okay, and then we're only interested in how does this superposition look like. Wave 3 is wave 1 plus wave. And we can make it a little bit simpler. We assume that the first waves, the original waves, have an amplitude of 1 unit. And here you can see in this graph, you can see some snapshots of waves, wave 1 and wave 2. You can see the wave varies between -1 and +1, both of these. And you can also see the superposition wave 1 plus 2. This is the superposed wave. And you can see that in some regions, the wave signals cancel out each other. Okay, in this region here. Okay. This is also called a negative negative interaction. Okay, a negative interaction. In other regions, we can see that the signals add up and amplify each other. You can see here in this region that the amplitude exceeds. Okay, this is a constructive interference. Okay? And then we can play around. So you can actually do that in Excel or so, but I've created these files here all using Fortran. Okay, you can easily do that. Okay? And then you can play around. And I want to present you 5 cases. Okay? In the first case, we consider the same wavelength but slightly different period. In the second case, same periods but slightly different wavelengths. Okay? In case 3, we use the same properties. Both waves have the same properties but opposite propagation direction. And you can achieve that by just changing the sign in front of where the period is. Just one term in the sine function, you change from positive to negative or negative to. And then I'll show you some more. Again, you will be amazed how many different types of interference patterns. Okay, look at the first case. It's this one here, same wavelength, but slightly different periods. Okay, what you can see is that the wave 1 plus 2, some points in time, you get an amplitude of 2, you get a constructive interference. At other times, you get the signal is wiped out. And something like this actually happens with the tides, or can happen with the tides. And here in South Australia, we call it the Dodge tide. There are 2 tidal constituents which at some time during the month cancel out each other. Okay, it's the 2 different tidal constituents, 2 waves, which almost perfectly cancel out each other, called the Dodge tide. Okay, let's have a look at the next case. Same periods, but slightly different wavelengths. This situation creates something that we call a wave group. You can see in the superposed signal here, you get a region of maximum amplitude, but this region actually slowly moves at a certain speed. And the associated speed, we call it the group speed. Speed is actually totally different to the original speed of 2 waves, the original 2 waves. Okay, so having 2 waves makes the consideration of the propagation much more difficult, because there you get very complex features like a wave group that propagates into a certain direction. So now the third example is the one where you have the same waves but propagating into opposite directions. Let's have a look at that. It's this example, okay? And this creates something special. It's called a standing wave. So this is a wave where it actually, where actually the wave just moves up and down, okay? There is no propagation at all. So you just get a wave which moves up and down and up and down at all locations. In some locations, there is no vertical movement at all. We call them wave nodes. And these type of stationary waves result from reflection at a boundary. The wave bounces against the boundary and moves backwards, interferes with the incoming incident signal, it creates a standing wave. And I just show it again. Let's see whether I can show it again. Here it is again. It just moves up and down and up and down. You can see the wave peaks. There is no horizontal phase movement of this. All right, so let's have a look at another example. Okay. This is one example, opposite propagation direction and different wavelengths and periods. You can really get some really weird pattern, and you can see that overall this combined wave turns out to actually move slowly into the negative x direction. You get these weird. And I want to show you one more. This example where you actually get wave packets which propagate at a very, very fast speed into the negative x. Okay? All right, so this is what you get. This is what we call the superposition of waves, and there is no real physics behind that. Okay, the physics, it might be involved in the creation of these individual waves, but the combination of the waves, there's no physics. It's just a pure superposition of signals. The one wave wants to go up, the other one wants to go down. You get a compensation of this. Or the waves amplify each other. So this is really fascinating stuff. It's called wave interference. Okay, so thanks for tuning in. Okay, so in the next lecture, you will be learning of how to develop a computer-based model to simulate these waves. Okay, thanks.